Today I'm going to present our report on Experiment 6, Monitoring of Forest Recovery After Typhoon Karathon, a case study based on Macaranga tenarius and its associated animals. Here are our group members. Outline. We divide today's presentation into 6 main sections. For the introduction, we will break it down into 4 small topics to help you better understand. Introduction. The role of typhoons in Taiwan's environment. When we think of typhoons, we often associate them with the disaster they bring to the natural environment. Typhoons impact Taiwan's forest ecosystems through strong winds and heavy rainfall. It might cause some serious damage. Despite of it, typhoons are also one of main source of Taiwan's water resource. On the right side of this slide, we can see an image of Shaolin Village, which was totally destroyed in 2009 due to the typhoon. Typhoons did turbulence to forest. Tropical cyclones caused abundant tree mortality, resulting in 46% of decrease in steam basal area. And how do we analysis on the damage and recovery of typhoon? To study the damage, we use UAV imagery. By using this technology, we can create high-resolution images to visually identify and measure the damage caused by typhoons. And here's our 5 interpretive marks: fallen trees, fallen tree areas, damaged buildings, parking spaces, fallen street lamps. And after a typhoon passed through, immediate impact occurred. Typhoons caused forests to lose significant amount of foliage. However, just in a few months, most trees were able to regenerate their leaves. The ability of forests to regrow is much better than we think. Next, the role of littorfall and nutrition cycling. After a typhoon, the increased littorfall contributes essential nutrients back to soil, which is vital for forest recovery. Typhoons can facilitate the cycling of nutrients in the soil, which improves the growth of forest. Therefore, we can conclude that the typhoon is not only causing a negative effect, but also some positive benefits. The role of forest resilience is also important. Here's are the difference between the resilience and resistance. Resistance means the ability to withstand strong wind and heavy rains. Resilience means the ability to use nutrients to regrow. According to the study, the forest with better resistance always tends to have better ability to recover. This slide shows how seriously the Sosan National Natural Park was damaged by the Typhoon Karathon. 26.6% of total area was affected by the typhoon, and we compare the before and after, we can see that the pathway has been seriously destroyed. And here's are the reasons for selecting Macaranga tenarius. Macaranga tenarius has a low height for easy examination of ecology on the leaves. Second, large leaves for measuring the length of a leaf. This slide shows the problem and predictions. Problems need to be solved. First, how to observe and record the growth of plants. Second, the relationship between animals and plants. Third, the relationship between the phenology of tree and their recovery ability after disturbance. And here's are the purpose of survey. We are selecting Macarenga Tenarius as observation target, and monitoring was conducted in two areas. One is disaster affected zone, and another one is unaffected zone. We also have to evaluate the resilience and resistance of Sosan forest. Selection of tree species. The size of Macarenga tenarius is small to medium size. Trees up to 20 meters tall, usually much shorter. Flowering period is February to April. However, we also found research indicate that Macarenga tenarius has second time flowering period in October to December, and its distribution is all over Asia. Material and method. Selection of study areas. We select parking lot of Eldon, which is affected areas, and Wooling Road intersection, which is unaffected area. These two locations are easily accessible and observable, allowing for observation every 2 to 3 days. And here's our observing method and how do we get the data. We conduct observation every 2 to 3 days to ensure that no plant growth phenomena are overlooked. We use a ruler to measure the length of fixed leaves, attempting to observe the leaf growth rate and thereby infer the plant's recovery capacity after typhoon. We also attempt to observe the animal on Macarenga, learning to identify the species, determine whether they are specific to the plant, and understand the relationship between associated animal and the plant after the typhoon. And each time we take photo, we try to keep the camera angle as consistent as possible. In addition, we select leaves of similar size for observation. And here's our current work in progress. The two Macarenga observed a parking lot of Eldon both show signs of damage, with broken branches, which is presumed to have been caused by Typhoon Karaton. We have been observed that after typhoon, Macarenga has grown several sprouts. We also observed insects and spiders on Macarenga. Thrips are the predominant flower visitor of both trees of Macarenga. However, they are not exclusive to Macarenga. And we find Taiwan yellow toxic moth in Moulin Road intersection. Leaves are damaged either at the center or toward the edges. However, they are not exclusive to the Macarenga either. And here's our problem unsolved. First, through a literature review, we should identify the interaction between these organisms and Macarenga, as well as determine whether these species are exclusive to Macarenga tenarius. Second, associated animals are difficult to observe, so observation frequency should be increased. Third, we still need to correctly identify the species we observed. Currently, we can only determine the family of some species. Last one, know enough data of leaf length to compare the difference between affected area and unaffected area. Thanks for listening.